Video problem 46, limiting reactants. So still sticking with stoichiometry. It's going to be very similar to video problem number 45, except instead of just looking for the limiting reactant, we are going to look for grams of a product that is formed. Okay, so let's go ahead and try it out. We have how many grams of bromine? So that's what I'm looking for, grams of bromine. How many grams of bromine will form if 76.4 grams of C2H3Br3, ooh, that's a wacky compound, 76.4 grams, is reacted with 49.1 grams of oxygen. So I get 49.1 grams of oxygen. I don't know why I don't zoom these in. There you go, that's a little better. All right, so again, what am I going to do? I'm going to go from grams to moles, moles to moles, and then I'm going to go from grams to moles, moles to moles. I'm going to pick the smaller one and then convert the smaller one to grams. All right, so let's go ahead and start out with the C2H3Br3. We've got 76.4 grams of that substance. I'm first going to convert that to moles. So mole goes on top, grams on bottom. Let's go ahead and get the molar mass of that. It's going to be pretty big. Those three bromines are really pretty big. So that's 266.744, so 1 mole is 266.744 grams. All right, I'm going to write that down up here. You always have to show your work, so even though I didn't here, I'll go ahead and do it. You can't not show this work. Show this work every time. It'll get you points. Okay, so that ended up being 266.744. Okay, now I'm going to convert that. That gives me moles of C2H3Br3. Now I'm going to convert it to moles of bromine. So I got C2H3Br3 on bottom. I've got Br2 on top, 6 Br2s for every 4 of those. So let's get that answer, 76.4 divided by 266.744 times 6 divided by 4. Watch your order of operations, okay? Make sure you're plugging it into the calculator, right? So this gets me, hold on, I gotta shut it down and bring it back up. Timeout. Okay, game on. Sorry, I had to restart OneNote. So let's see, I did all that and my answer ended up being 0.4296, and that's moles, let's see what all cancels out here, of Br2. Okay, moles of bromine. Now I'm going to do the exact same thing with the oxygen. All right, so I've got 49.1 grams of oxygen. Right? 1 mole of oxygen weighs 32 grams. I can do that down here. And then that gets me moles of oxygen. Now I'm going to go to moles of bromine. So I got 6 bromines for every 11 oxygens. 49.1 divided by 32 times 6 divided by 11. So I get a value of 0.837. And that's going to be moles of bromine. Okay, so this is the lesser amount. All right, I have fewer moles of bromine that come from the C2H3Br3, so that's my limiting reactant. I'm just going to put an LR on top of it to let me know. And then this is the value that I want to use to get grams of bromine. I will never use this number, never. Okay, so I got moles of bromine. I'm going to convert that to grams of bromine, so grams on top, moles on bottom. Each bromine is 79.9. So that's 159.8 grams for 1 mole. So let's go back up and grab that 0.42 number take that, and I'm going to multiply by that 159.8 number. So I get a value of, let's see, how many sig figs should I have? 3 sig figs, so 68.7 grams of bromine. So that's how many grams of bromine I actually form. And again, I never use that excess reactant, which is what this is. That's the excess reactant. All right, let's try another one. How many grams of carbon dioxide? So I'm looking for grams of CO2. Will be given off if 15 grams of ethane, so this is 15 grams of ethane, reacts with 16 grams of oxygen. So I got 16 grams of oxygen. My numbers are getting a little, should have made these equations a little bigger, huh? Spread them out a little bit. Same idea, okay? I'm just going to go from grams to moles, moles to moles, and then grams to moles, moles to moles. All right, so let's start out with that ethane. I've got 15 grams of C2H6. Convert that to moles. So 1 mole for every, let's see what we get. So we got 2 times carbon, which is 24.02. 6 times hydrogen, which is 1.008 times 6, so it should be 6.048. Just make sure, yeah, 6.048. So that gives me what? 30.068. That's how many grams per mole. Right? So that's 30.068 grams. All right. And then I'm going to go ahead and convert that to moles of CO2. So I've got 4 CO2s for every 2 C2H6s. So I got 15 divided by that 30.068 times 2, basically, times 4 divided by 2. So that gives me 0.998, what I got, moles of CO2. I'm going to do the same thing with the oxygen. All right, so let's do that in blue. 16 grams of oxygen, 1 mole for every 32 grams. Right? So grams cancel out. Now I have moles of oxygen. We're going to go to moles of CO2. So 4 CO2s for every 7 oxygens. Right, so let's see what we get. 16 divided by 32, which is 0.5, times 4 divided by 7. So we get a value of 0.286 moles of CO2. I'm not writing of. CO2. All right. So this oxygen is my limiting reactant. All right. I'm going to convert that to grams. So I've got 44.01 grams for every 1 mole. And I get a value of 12.6. 12.6 grams of CO2. All right. Remember, you never use the excess reactant product. Okay?